48 hours. That is all it takes. A shallow container of water. A handful of green specks, smaller than rice grains. No soil, no weeding, no months of waiting, just protein, doubling, every 2 days. NASA scientists tested every plant imaginable for space stations. Lettuce, soybeans, wheat. One plant outperformed them all. They called it the most protein-dense plant on the planet. Thai grandmothers have harvested it from buckets for centuries. They call it eggs of the water. Yet almost no one in the West has heard of it. Two forces explain this silence. One is economic. The other is a century of misdirection about what protein production requires. By the end of this video, you will know the exact setup that transforms any climate into a protein factory. A kitchen window in Minnesota, a balcony in Dubai, a basement in London, all of them work. But first, you need to understand what was hidden and why. Welcome back to Secrets Beneath Nature. For generations in northern Thailand, families have harvested tiny green spheres from still water. They call it kai nam, eggs of the water. Their grandchildren call it breakfast. No farm needed, no fertilizer purchased. Just a wooden bucket, calm water, and patience measured in hours. The plant floats on drainage ditches and quiet ponds from November through July. Villagers scoop it fresh for omelets and curries. A protein source so obvious, they never needed to call it superfood. The plant itself defies everything you think you know about agriculture. Wolfia globosa, the smallest flowering plant on Earth. No roots, no stems, no leaves. Just pure photosynthesis machinery, smaller than a grain of rice. Fit dozens on a single fingernail. Bright green, soft, almost silky when fresh. Then scientists began measuring what indigenous communities already understood. Dr. Eric Lam at Rutgers University spent decades carefully documenting its extraordinary potential. Ziegler and colleagues published findings in plant biology, classifying duckweeds as the most rapidly growing higher plants ever studied. 39 clones, 13 species. The results held consistent. What a Thai grandmother knew from observation. Laboratories confirmed with data. But the numbers that followed made researchers question everything they thought they knew about protein production. Let me show you the numbers that should not exist. The Journal of Agricultural and Food Chemistry published findings in 2025 that made researchers re-examine their assumptions. Wolfia arhiza contains 30 to 51% protein by dry weight. Lemna minor reaches 35 to 45%. A study in food chemistry found that under optimized conditions, protein content climbed to 51%. For comparison, beef contains about 26% protein. Eggs come in around 13%. Soybeans, the supposed gold standard of plant protein, reach 36% on a good day. This tiny floating plant outperforms them all. The amino acid profile is complete. Every essential amino acid present. Meeting or exceeding World Health Organization requirements for human nutrition. The protein inside is primarily rubisco, the most abundant protein on Earth. The same molecule that powers photosynthesis in every green plant, concentrated into something you can eat directly. Here is where conventional biology falls apart. Ziegler and colleagues published their study in plant biology in 2015. They tested 39 clones from 13 species under standardized laboratory conditions. Doubling times ranged from 1.34 to 4.54 days. Indoor cultivation pushed this further. A 2022 paper in the Journal of Cleaner Production documented doubling times as fast as 1.24 days. Compare this to anything else you might grow. Soybeans require 90 days minimum from planting to harvest. Beef cattle need 18 months to reach slaughter weight. This plant doubles its mass before most people remember to water their houseplants. Night growth equals or exceeds day growth in some species. It never stops. Now here is where industrial agriculture loses the argument entirely. Sosa and colleagues compiled yield data across multiple studies in 2024. Duckweed produces 2,080 kilograms of protein per hectare per year. Soybeans produce 303 kilograms. Corn produces 179 kilograms. That is not a small difference. Duckweed delivers nearly 7 times more protein per unit of land than soy, 10 times more than corn. The Journal of Agricultural and Food Chemistry confirmed biomass yields reaching 30 tons of dry matter per hectare annually. You can harvest multiple times per week. One researcher summarized it simply. The surface of a small pond can outproduce an entire soybean field. The climate tolerance destroys every excuse for regional limitations. This plant grows at temperatures as low as 1 to 3 degrees Celsius. It survives light freezes. Optimal growth occurs between 20 and 30 degrees Celsius, but it tolerates far wider ranges. The pH window spans 5 to 10. Most crops demand 6 to 7.5. Duckweed thrives in conditions that would kill your tomatoes. Global distribution covers every climate zone except true desert and Arctic tundra. From Thailand to Minnesota to Scotland, the excuses evaporate. Dr. Eric Lam at Rutgers University built something that redefines scale. His vertical farming prototype spans 2.5 acres of stacked trays. Annual production reaches 1.4 million pounds of dried plant matter. That is 50 times the output of corn on equivalent ground area. Water depth requirement is just 5 centimeters, 2 inches. A basement becomes a protein factory. Then NASA validated everything. The Translational Research Institute for Space Health partnered with University of Colorado Boulder. Dr. Barbara Demig-Adams led research published in 2020. Their conclusion shook the space food program. Duckweed is the most protein-dense plant on the planet. It produces zeaxanthin and lutein, radiation-fighting antioxidants critical for astronaut health. It thrives under artificial light at half-normal sunlight intensity. NASA's Space Lab tested it on Blue Origin's suborbital flight in 2023. The same plant Thai grandmothers harvest from buckets now informs how we will feed humans in orbit. So why did this knowledge disappear from Western awareness? 3 forces converge to bury this knowledge. The first is visual prejudice. Western agriculture values appearance and scale. A cornfield stretching to the horizon photographs beautifully for farm subsidies and marketing campaigns. It signals productivity. It wins awards. A plant you need a magnifying glass to appreciate does not command the same respect. It looks like pond scum. Nobody brags about their floating green carpet the way they brag about their tomato harvest. Industrial agriculture optimized for spectacle, not efficiency. Indigenous foods dismissed as primitive curiosities rather than sophisticated solutions. The second force is economic disruption. Duckweed cannot be patented in its natural form. It reproduces by splitting in half. No seed company profits from something that copies itself for free. No equipment manufacturer sells specialized duckweed tractors. No processing facility stands between you and your food. Every middleman in the industrial food chain loses money when you grow protein in a bucket. The global soybean industry exceeds $150 billion annually. Corn depends on seed purchases, fertilizers, pesticides, and specialized machinery. Duckweed threatens the entire model. No lobby defends it. No corporation advertises it. No trade association promotes it. The silence is not accidental. The third force is systemic dependency on complexity. Industrial food systems require long supply chains, storage infrastructure, processing facilities, transportation networks. A plant that grows itself in any container undermines the architecture. Simple solutions do not generate consulting fees. Academic funding follows commercial interests. Research dollars flow toward patentable innovations. Duckweed studies remained buried in niche journals while billions funded crops that required billion-dollar infrastructure. But in northern Thailand, Myanmar, Laos, and Cambodia, this knowledge never disappeared. The Jirkus database lists Wolffia globosa among traditional vegetables harvested from natural waterways and sold in local markets. The European Food Safety Authority confirmed in 2021 what communities knew for centuries. They call it Kai Nam. They serve it fresh. They never needed to rediscover what they never forgot. Then space travel changed the equation. NASA needed food that grew fast in small spaces with minimal inputs. Suddenly, efficiency mattered to people with funding. The University of Colorado Boulder published findings in 2020. Commercial ventures followed. Plantable Foods raised $30 million. Hinnuman brought products to market. Green Onyx built vertical farming systems. The market now projects $246 million by 2035. What grandmothers harvested for free now commands premium prices in health food stores. But you do not need to buy it. I promised you the exact setup. Here it is. You need any container that holds water. A 5-gallon bucket works perfectly. A plastic storage bin works too. A kiddie pool for larger production. Even a glass baking dish on a windowsill will do. Choose shallow and wide over deep and narrow. Duckweed only grows on the surface. Depth is wasted space. 5 centimeters of water is plenty. 2 inches. More surface area means more growth. Start with a single container. Scale up once you see it working. For water, use dechlorinated tap water. Let it sit overnight in an open container. The chlorine evaporates naturally. Rainwater works even better. Pond water is ideal if you have access to a clean source. A water conditioner from any pet store accelerates the process if you cannot wait. The pH should fall between 6 and 7.5. Most tap water already qualifies. Test strips cost a few dollars at garden centers. Avoid distilled water. It lacks the minerals duckweed needs. The water your houseplants drink works perfectly. Nutrients determine protein content. Fish tank water is ideal. The nitrogen from fish waste provides exactly what duckweed craves. No aquarium? Dilute any balanced liquid fertilizer to 1/5 the strength recommended on the label. A few drops of aquarium plant food each week sustains growth. Even a single decaying leaf provides enough organic matter to get started. Compost tea works well for ongoing nutrition. Higher nitrogen produces higher protein. The 2024 food chemistry study confirmed this relationship. Avoid over-fertilization. It promotes algae competition. Less is more until you understand your system. Now the duckweed itself. Float your starter culture on the surface. Cover 10 to 20% of the water initially. You can find duckweed in local ponds if the water source is clean. Order it online from aquatic plant suppliers. Ask aquarium hobbyists in your community. 1 tablespoon is enough to start an entire bucket. You need far less than you think. Place your container where it receives bright indirect light. 6 hours minimum. A sunny window works. A shaded patio will do. Direct hot sun all day can overheat the water, but duckweed tolerates more variation than you expect. Temperature range between 60 and 90 degrees Fahrenheit is ideal. LED grow lights enable year-round indoor production. Half the intensity of normal sunlight is sufficient. NASA confirmed this. That is the entire setup. Walk away. 48 to 72 hours later, the coverage has doubled. You will not believe how fast it happens until you see it yourself. By day 5, you can harvest. Skim half the surface with a small net or kitchen strainer. Leave the other half to keep growing. Rinse the harvested plants. Pat dry. Use them fresh in salads, smoothies, or scrambled eggs. Spread thin on a tray to dry for protein powder. One critical warning: never dump duckweed into natural waterways. It can become invasive in some regions. Compost any excess. Feed it to chickens. Tilapia farmers cut feed costs by 50% using duckweed. Backyard chicken keepers notice egg yolks turning deeper orange within weeks. They told us protein requires vast land, months of waiting, industrial machinery, expensive inputs. They told us dependence was inevitable. Here is what they never wanted you to understand. The solution floated on every neglected pond and forgotten drainage ditch. 48 hours. Any container. Any climate with basic light and warmth. Complete protein. Self-replicating. requiring nothing you cannot provide yourself. The Thai grandmother harvesting kai nam from her bucket knew something the industrial food system spent a century trying to make us forget. NASA scientists running space food experiments confirmed what she always understood. And now you know too. Protein independence was never impossible. It was merely hidden. If you found this valuable, watch the next video and do not forget to subscribe. See you in the next one.